Welcome to Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker, and welcome to this little mini Fragment episode. This episode of Fragmented is brought to you by Rollbar. With Rollbar, you get the context, insights, and control you need to find and fix bugs faster. You see, here's the reason why I like Rollbar. There's many times when I have errors on the client side, which is, the Android app, and then sometimes I'll also have it on the server side, such as if it's in Rails or Node.js or whatever it may be in, and I'm trying to track an application error from end to end. It's very difficult. I have to look in multiple different crash reporting systems. Well, Rollbar simplifies this. They have an Android client and also numerous different languages and framework support for server side as well. So I can actually track these errors from end to end. It also integrates with a bunch of other different cool things such as GitHub, Jira, Slack, all the cool things that we all used before. So if you're interested in learning more about Rollbar, you can go to rollbar.com/fragmented. And you will get the Bootstrap plan for free for 90 days, which includes 300,000 errors tracked for free. All right, again, that's rollbar.com/fragment. For those of you not listening, the mini Fragment episodes are short little tidbits for a few minutes long where we talk about various different pieces of Android and software engineering and computer science and all that goodness. Right now, we're covering some items from Joshua Bloch's Effective Java book. Today, we're going to talk about item number 8. And let's just hop right into it. Item number 8 in Effective Java, again, the second edition is one we're looking at here. It says to obey the general contract when overriding equals. And that's the method equals that you find on a regular Java object. Now, there's a lot of things that can go wrong that Joshua says here when you override equals and kind of give some tips and tricks, which we'll cover here in a second. But there's a lot of things that we can do wrong as well. And one of the big things he says is the easiest way to avoid problems is not to override the equal methods at all and just let the class only be equal to an instance of itself. So it's kind of self-explanatory, right? And this might be the right thing to do if any of the following conditions apply. If each instance of the class is inherently unique. So if there's no other type of properties, a customer, in this case, a customer object maybe not fall into that category because if the customer object has the same customer details, maybe it's the same customer. Another one is you don't care whether the class provides a logical equality test. For example, the Java random class could have even overridden the equals class, but it did not because they don't really care if two random instances are equal to each other. And in this case, because it's just a random class. Another instance where this is okay is a superclass has already overridden the equals method above it. So again, the superclass is overridden equals and the behavior is appropriate for the class you're working in, so no need to override the equals in your class. And the final option here is that the class is private or package private, and you're certain that the equals method will never be invoked. So those are going to be weird situations, but sometimes they can arise. So when is it appropriate to override object.equals? Well, when a class has the notion of logical equality that differs from mere object identity, blah, 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 that doesn't make any sense when we read it, so let's break it down to actual English here and talk about when it makes sense to use object.equals and to override it. Now, the equals method implements what's called equivalence relation, and equivalence relation has basically 4 little subsections and kind of a fifth one if you think about it. One is reflexive, another one is symmetric, another one means that the object is transitive, that the equality is transitive, and consistent is the fourth one, and the fifth one that kind of doesn't really have a name. It just basically says for any non-null reference of value x.equals null must return false. So let's go ahead and hop in and talk about the first one, reflexive. Now the first one, being reflexive, basically is adhering to reflexivity. And that basically says that a object is merely equivalent to itself. So that's kind of self-explanatory, right? Now the next one is symmetry. And the second requirement basically says that any two objects must agree on whether or not they are equal. Unlike the first requirement, it's not hard to imagine violating this one unintentionally. And I think Joshua provides a good example of here where you're using a case-insensitive string and a string. And it's kind of hard to imagine this without seeing the code. But long story short, the case of a string is preserved by the toString method. but is ignored in comparisons. And so he gives an example of how you're comparing two different strings. One's a case-insensitive string, one is a case-insensitive string, and it only provides one-way interoperability. So there is not symmetry there, so it doesn't actually conform to the equality statements which we're trying to adhere to. Now, a well-intentioned equals method sometimes will naively attempt to interoperate with these ordinary strings, but in this case, he's using the case-insensitive string class and trying to compare it to a regular string class, and you can actually see the difference of why this may not work. So long story short, we want to make sure that we have symmetry between objects and whether or not they agree that they are equal. So if we want two classes, we want to make sure that they are agreeing on what is equal across the board. So the third requirement of the equals contract says that one object is equal to the second and the second is equal to the third, then the first object must be equal to a third. Hey, it's like algebra class all over again, right? Like A equals B equals C means C equals A, right? I know, this is fun. Welcome to the fragmented math class. Now, I'm not really going to dig too deep into this one here because it's kind of obvious what this really means. If A equals B and B equals C, then C equals A kind of thing. But Joshua does go into a lot of detail kind of describing symmetry, transitivity inside of this section number 8, and many pages actually where he's describing how to use different points and how to check it out. So if you have the book, definitely open up section 8. I think it might be one of the longest sections in the book actually. I was looking on the Kindle version I have here, and just section 8 takes up over 2.5% of the entire book, which is amazing considering there's over 50 of these things, which is pretty amazing. But there is one important thing here to note in a computer science and an engineering type of area. And basically, Joshua lists the Liskov substitution principle states that any important property of a type should also hold for its subtypes so that any method written for the type should work equally well on its subtypes. So kind of again, that whole A equals B equals C. So any of the subtype methods should work with the other types that have been subclassed accordingly. Now, there is, of course, always gotchas. We are working in programming in Java for that matter. There is a couple of things that he does mention inside of this regarding transitivity, which part of the actual core Java stuff kind of breaks down. And for example, the java.sql.timestamp class extends java.util.date, and it adds a nanoseconds field. The equals implementation for the timestamp class, in fact, does violate symmetry and can cause basically erratic behavior if the timestamp and the date objects are used like in the same collection or list or otherwise mixed up here. Now, if you look at the timestamp class, there is some disclaimers in the code cautioning programmers against mixing dates and timestamps and so forth. So as long as you keep them separate, you should be all right. But this isn't an actual example of where this symmetry is not followed in transitivity and so forth inside of the actual core Java itself, which is kind of interesting. And item number 4 here is consistency. And the fourth requirement basically states that if two objects are equal, they must remain equal for all time unless one of them is modified. So, in other words, to quote the book here, it says, in other words, mutable objects can be equal to different objects at different times while immutable objects can't. The high-level overview again is they must remain equal for all time unless they are modified. So if they're both the same objects, you have, two person objects, the same fields, etc. This equality matches. They're the same until one of them changes. That's pretty much what it's saying. There is, of course, again, more caveats. Whether or not your class is immutable or not, that kind of does define on whether you should write an equals method. And as an example, you shouldn't write an equals method on something that depends on unreliable resources. And the perfect example is given right here in the book. And it basically says that java.net.urls equals method relies on a comparison of IP addresses for the hosts associated with URLs. And translating a host name to an IP address does require network access. And if there is not network access, or you have proxies in the way or something, you could get different results. So it's unreliable. We can't really implement something and should not implement something in that regard that tests for equality. And the final contract requirement here, which didn't really have a name, it was kind of like, well, maybe it is, maybe it isn't a contract requirement, was actually given a name, and Joshua calls it non-nullity. And he just gave it that name because it had an absence of a name, so we'll just call it non-nullity. We'll just roll with it. And it basically says all objects must be unequal to null. Pretty self-explanatory. I don't think we need to really get too far into that one. Now that kind of wraps up the contract requirements for what a equals method should be implementing. Now, there are a couple of tips, I believe 5 tips here, which are provided to make sure that you implement a high quality equals method. I bet you really never thought we'd be talking about how you can implement a high quality equals method. I never thought I'd actually say those words myself, but here we are. Anyway, let's hop right into it. Number 1, you need to use the equals operator to check if the argument is a reference to this object. If so, then return true. This is just performance optimization, but it's one worth doing if the comparison is somewhat or potentially expensive. Now, number 2, use the instance of operator to check if the argument has the correct type. And if not, then you should return false. We'll go to number 3, cast the argument to the correct type. Because this cast was preceded by an instance of test, it's guaranteed to succeed. And number 4, for each significant field in the class, check if that field of the argument matches the corresponding field of this object. So kind of self-explanatory. If you have a name object name field, it's matching the name field of this object, and so forth, and all the way down the line. And finally, the 5th item here is probably the most important thing in this entire mini fragment here. And it basically says, when you're finished writing your equals method, ask yourself 3 questions. Is it symmetric? Is it transitive? And is it consistent? Now here's where the real important part comes in. Now turn it up. Turn the volume up. Right there on the radio. If you're in your car, just turn it up. Maybe, you know what? If you're in your car, I want you to pull over. I want you to get off the side of the road. I want you to just put it in park and just listen real closely here, okay? I'm going to give you about 3 seconds. I know it's not enough, but hey, we'll pretend like 1001, 1002. Okay, listen, here it goes. And don't just ask yourself these questions and say, oh yeah, it looks like it works. Write the unit test to make sure that these properties hold, because if you don't, then how do you not know? I can't tell you how many times I see someone say, well, I wrote the code, it works. I'm like, well, do you have a test? No, there's no test. So write the test, people. Please write the test. Now, Joshua does provide in the book. If you don't have it, I recommend you go pick it up, because there's, again, this item number 8 is like ginormous inside of the book. It took me like 4 days to read it. No, I'm just kidding. It's very large though, and he does provide an example in item 9. There is some code in item 9 where it says, for a full example of constructing a good equals method, check out the phone number.equals thing in item 9. He does also include a few final caveats. One is always override the hash code when you override equals, so that's kind of listed in item number 9. Don't be too clever, so don't get too hardcore and aggressive in searching for equivalence. That's easy to get yourself in trouble and not really quit equivalence, and you might just accidentally get it wrong. 3, don't substitute another type for object in the equals declaration. Now I'm going to paraphrase here. It says, it's not uncommon for a programmer to write an equals method that looks like something like the following. You could spend hours puzzling over why it doesn't work. And basically that code is public boolean equals my class object, blah, blah, blah. The problem is it doesn't override object.equals. So you're not overriding the object to equals. You're just kind of creating your own little equals method. So make sure you're overriding the correct one and use the override annotation. And that pretty much wraps it up for today. Again, like I said, number 8 was long. If you get anything from this, it's if you are writing a equals method, make sure that you check that it's symmetric. Make sure you check that it's transitive. And make sure you check that it's consistent. And finally, most of all, just write some unit tests. You'll sleep better at night. I know I will. All right. I'll talk to you guys later. Have a good one. Once again, we want to thank our sponsor for this episode, Rollbar. With Rollbar, you get the context, insights, and control you need to find and fix bugs faster. Go to rollbar.com/fragmented to get the Bootstrap plan for free for 90 days, which includes 300,000 errors tracked for free.